Here we're going to look at an example of how I can use trigonometry to find lengths in a right angle triangle. So here we're given a triangle with vertices x, y and z, and I'm supposed to find the length x and the length y in the triangle. What am I given? I'm given that this side is 5 long, and I'm also given this angle here, which is 65 degrees. Since we're going to be using so, ka, toa as before, let's see if we can identify anything on that triangle already. Well, the hypotenuse is always the easiest to find because it's the longest side and it's also opposite the right angle in the triangle. And then remember, we have to focus on an angle. So opposite of the angle of 65 degrees is this side. So that's going to be the opposite here. And next to it is this side here. That's the adjacent. So already I know that the adjacent is 5. My angle is 65 degrees. Okay, and let's start with finding x. Okay, so for x, let's note down that we have the hypotenuse involved, since that's what x is, and also we're looking for to use the information we have, the adjacent, because we know that the adjacent is 5. So now we need to hunt here in so, ka, toa, which one of these looks like a promising ratio to use. Is it sine, is it cosine, or is it tangent? Well, I want to be using the hypotenuse and the adjacent. Where do these come up? Is it sine, is it cosine, is it tangent? Well, it's going to be cosine, because here I've got the adjacent and the hypotenuse. Cosine seems like the right ratio to use. Cosine, remember, it's always of an angle. Cosine 65 degrees. According to this ka part, it's the adjacent over the hypotenuse. And if I fill in the information, well, the adjacent is 5 and the hypotenuse is x. So if I write out this equation in short, like this, you will recognize that this follows the pattern of equations we've discussed at the beginning of the unit. It's of this form where x, the unknown, is in the denominator, and you will remember this was a two-step equation where I need to multiply by x first to get ax equals to b, and then divide by a in order to get x on its own, x equals b over a. So we're going to use that here, right? So if I follow the patterns here on the left, okay, I will solve this and get x equals to 5 over cosine 65 degrees, right? And my calculator knows what 5 divided by cosine 65 degrees is. So let's press enter, and I'm going to give my result here to approximately 3 significant figures. It's about 11.8. So it's approximately 11.8 units long. I've just calculated x. Now I would like to calculate y. So if I write this down, let's see what's involved with the length y. Well, I know that y is the opposite of my angle of 65 degrees. And as before, I know the adjacent. That was given in the problem. The adjacent is 5. So again, given the opposite and the adjacent, where is it that I will find this? Is it sine? Is it cosine? Is it tangent? Look carefully, and you will see that the tangent ratio is the one that involves the opposite and the adjacent. So I will be using tan. Let's see. tan 65 degrees equals, I'm setting up an equation here, let's write down the definition first, is the opposite over adjacent. The opposite is y, and the adjacent is 5, as before. Let's write this out as an equation. Y over 5, this is y. Okay, and you will notice that this follows the basic pattern A equals y over b. Or, actually I was using x, so I should write x over b. The unknown with two numbers like this. And to solve for x I need to multiply by b, so I get ab equals to x. I need to do that here too. I multiply by 5 and I'm getting 5 times tangent 65 degrees equals to y. Let's get this on the calculator. 5 times tan 65 degrees, press enter, and I'm getting that y is approximately 10.7. Right, and now I've calculated the length of y and the length of x. And let's finish with a question I'd like you to think about, and we'll discuss that in class. We'll discuss your answers in class. Find at least 2 other ways in which I could have calculated the length y. We've calculated the length x, and then we calculated length y using this technique here. I'd like you to think of 2 other ways to calculate y.